Hello, Terra Classic community. I thought I'd try something new today. So, most of you are far away from the core code, and that's totally okay. But maybe for some it's interesting to see something that happens behind the scenes. So, I want to use this for explaining a bit some changes in the market module for the MM2.0. So I have currently the message server open on the screen. You can see here the swap function. The swap function is where you land, or where the system lands, if you send a swap request for the market module. So this just checks the address, who wants to trade, if it's valid, and then continues to the handle swap request. And if we go further, we check the handle swap request. And when we go through this, it checks if it is an allowed swap denom, and then it fetches the LUNC exchange rate. This is where the Oracle prices are stored. So every 30 seconds the validators vote on prices for different tokens like Euro and Malaysian and US dollar, and all that stuff is calculated in a way that we know, okay, what price has LUNC in this specific currency. So on chain we have the information how much is each LUNC in US dollar, in Euro, and so on. And this is read here. So then we check, okay, when was the last time that the Oracle has successfully voted on the prices? And this is a new part of the safeguards in the system for the MM2.0. If you check here, it checks, okay, has there been a latest voting time? Yeah. How is the current time currently for the current block that shall be executed, where the swap happens in? And then it checks, okay, what is the governance parameter? How old are those votes allowed to be? And if the seconds since the last vote is too high, it simply, it errors out. It returns an error and does not execute the swap. This is something that was not there before. That means if a block gets delayed due to external attacks or something like that and doesn't take 5 seconds, but for example it takes, like, let's say it takes 2 minutes, we might not want to use outdated prices for swaps, so this is a safeguard added. And then we come here. This is the compute swap function. The compute swap function is there to calculate, okay, what is the user offering and how much and what does he get in return. And there is a lot of computation in here. Most of that is not really interesting for the most of you, I guess. But this is, to a big part, this is not really changed much. It calculates the spread, it calculates the prices again, and all that stuff that is already there in the current market module that is stopped. It checks the Tobin tags. Sorry. And if we check here, it calculates the exchange rate for the offer denom. It calculates the exchange rate for the other denom. So you have both exchange rate. That means if someone would, which is not allowed, but if someone would change Euro to US dollar, we would have both prices of LUNC, the price in US dollar, the price in Euro, and so we can calculate the exchange rate of Euro and US dollar, because we have both prices for LUNC. And that is what happens here. The return amount is calculated. Okay, if we go back, this is all calculation, how much is there, and it's yeah, it's very technical. It's kind of the virtual AMM, so something that the DEXs do to calculate the prices, and similar of that is done here. So here is another safeguard that was added, and that is the deviation of the current price. So we do not want to allow swaps when the price that's currently there is too far away from the previous prices. And in that case, if it's too far away, which is also a governance parameter, then we disallow the swap again. We return an error because we don't want that. So here is fee calculation, here is applying the swap to pool. That means the virtual AMM pool. That would go far too deep here to explain how the internal swap pools of AMMs work, but you can kind of think of it that if you exchange tokens in a DEX, then one side of the reserves gets lower and one side gets higher, and from this ratio of the two it calculates prices. But yeah, there's quite a bit more to it. Okay, here is another safeguard that was added. Check and update daily cap for swap. If we go there, it checks, okay, how much is allowed to be swapped on a daily basis. We don't want that, for example, if we have a swap limit of 100 million LUNC for the whole month, that it would be swapped in a single day. We want to limit it to a certain percentage per day. Not 1/30 of the month, but maybe 1/10. So also that is again a governance parameter, but it is meant to limit the daily swap amount, and that is calculated in here. Daily cap factor and cap usage, so how much was used, and this is reset daily. Okay, then the next is checking, okay, does the user get anything? Currently, for example, this is what currently disables the market module, because the Tobin tax, this is the tax when swapping stables, and the spread, that is when swapping stables with LUNC, has been set to 100%. So the user would get 0 no matter what he sends. And this is a check that prevents the user from getting 0. And that is how the market module was disabled. And so the market module wasn't even disabled in the code. It was disabled in a governance parameter. So if you would make a governance proposal lowering the Tobin tax without updating any code, you would have the old market module online again, which is dangerous. So, as you saw previously, the the checks and safeguards have been added before this point. Then further down, it checks, okay, what is the pool balance? What is the pool balance of the market module? And this is also new. Previously, this was where the market module minted. It didn't check, okay, what is the balance of this? The market module didn't have any balance. It just minted and then sent the coins to the user. And here we are now checking, okay, the module address of type's module name. Type's module name is market. This is the market module. It checks the balance of the market module and checks, oh, do I have enough tokens to send to the user what he wants to get? And if yes, okay, then I can send coins from module to account. I do not mint here. I send coins from the module balance to the user. Then the fees are calculated and so on. But this is the important point. You do not simply mint coins. You send them from the existing balance, and if there is no balance in the keeper here in the module, in the market module, then it cannot send anything out. And that is something very important. So this is how the swap happens in the first place. It sends out. And here you can see this is the part where it takes the coins from the user. Send coins from account to module, from the trader to the module name market. This is where it gets the coins. They are not burnt. They are received. And now if we look at what happens in the ABC. This is what is executed on each block. It checks, okay, process epoch if due. We have said we make an epoch. This means monthly. And here is the market module address. And this is a new address, a new module address, the market accumulator. This will get the share from the tax. It will be accumulated here. And once a month, when this is due, when the time is due, this balance from the market, from the new accumulator address, here, this is sent from the accumulator to the market module. And that means this is the amount that the market module has available for swapping in the next epoch. And before that, it checks, okay, what is left in the market address, in the module. What is left after the people swapped back and forth for the current epoch? What is left? And that is burnt. Here is burn coins from the module name, all the balances that are currently in there. That is what happens. And here you can see, after it did that, refreshed the balances, moved from the accumulator to the market module, it refreshes, okay, the daily cap baseline based on the new amounts for the next period. I hope I could explain a bit how the new market module adds some safeguards and doesn't use mint burn but adds accumulator, and yeah, then gets funds each epoch from that accumulator to use for swapping. Cheers.